how do we use chess to teach algebra? Well, chess just happens to be the language in which we're using to communicate to a Chessology student. We play a game called checkmate. It's a contest, it's something of a race to see who can create a checkmate position fastest. But the language that we use to dictate the pieces that are going to be used are algebraic in nature. So let's start with the king, of course, the reason why we all show up. 4 squares. The king can take 4 different positions. A8, A7, B7, B8. 1, 2, 3, 4, 5, 6. There are 6 different positions the king can take. Here in the center of the board, there are 9 different positions the king can take. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I am the king and you are my opponent, my king has 9 different possibilities. Do you know where my king is going to move? Of course you don't. Therefore, 9 unknowns. 9x. Makes total sense to me. Now, a Chessology student is taught that no matter which of these 9 x's we opt for, it's going to be equal to a particular idea that we teach. Chessology, that these 2 parentheses are actually the inside of your head. Maybe draw some ears, some hair up there. Yeah, why not? You got some hair up there. Alright, fine. Now, we got to introduce some variables into the equation. All we know right now is that the king has to be in the center of the board and there's 9 different possible positions. If we introduce some variables to the equation, let's say for example we got a couple of pawns hanging out on the board near the king. What are these pawns actually doing? They're keeping the king from moving in 2 of the squares. So of course, -2. Now, a Chessology student can grasp the concept of a negative number, because even though we've added 2 pieces to the board, we are taking away from the number of possibilities for my king to move. We're also going to add some enemy pieces. How are we going to achieve checkmate without enemy pieces? In this situation, let's take a couple of knights. Let's put one here. Let's put one here. These 2 squares are being attacked. These 2 squares are being attacked. Now, in order to express that, here, what we're going to say is we've added 2 knights. We could even do that. Now, a child understands exponential numbers, which is something of a multiplication. 2 times these knights. Now, we're knocking out 4 squares. We also need to go on ahead and attack these 3 final squares. We've got to attack the king in order to get check. We've got to attack the 2 remaining squares in order to get checkmate. So if I take a bishop, let's put him way out there. That bishop is still attacking 1, 2, 3 of the 9 squares. 3 of the 9 squares. Then we get into fractions, because this 3 of the total 9 squares is actually 1, 2, 3, 1/3, because there's only 1, 2, 3, 1, 2, 3 other squares. So 3 plus 3 is 6. We have these 3 plus 6 is 9, of course, which is our total. So 1, 2, 3 ninths. So then they learn to understand fractions. Now, of course, this can be simplified into, of course, 1/3, and eventually a child figures that out as well. So there you have it, a very, very quick explanation of pretty much how we use chess to communicate algebraic theory.